In Module 3, we're going to cover the MX6 operations. Let's start by taking a tour of the physical features of the MX6. At the top of the instrument, underneath those openings, is where your sensors are located. We have to ensure that we keep this area free and clear of obstructions. This is the only place that the instrument will see gas. Therefore, we have to keep these areas free of obstructions. If we allow any dirt or contaminants to get clogged in the inlet ports, then the sensors will not be able to see the gas. If the sensors cannot see the gas, then the instrument will not be able to detect the gas. The chassis of the instrument is a composite material with a rubber overmolding, which helps against shock or during drops. Down the corner of the instrument is where a wrist strap can be connected. At the bottom of the instrument is where your battery charging connections are located. This is for charging the optional lithium-ion battery pack. Right next to that is the IR communication port. This is for communication with the data link or when connected with the DS2 docking station. There's a 5-way navigational button that allows the user to navigate through the different operations of the MX6. At the center of the instrument is your LCD display. At the top of the instrument, underneath that opening, is where your visual indication of alarm condition. Whenever any one sensor goes in alarm, all 4 LEDs will start to flash. There's a 5-way navigational button that allows the user to move through the different operations of the MX6. There's an up arrow and a down arrow. There's a left arrow and a right arrow. And in the center is an on-off enter button. With any gas detection instrument, it is always recommended that before you use it, to take it through the 4 steps of operation. Industrial Scientific Corporation designs, manufactures, and sells instrumentation for the preservation of human life and property. Recognizing this fact, it is recommended that the user send the instrument through 4 basic steps of operation to ensure maximum operational readiness and capabilities before each day's use. The first step of operation is always to turn on the instrument and to check the battery status. With this, we're also going to ensure that the proper sensor configuration and the proper sensors are installed in the instrument for the job at hand. The second step of operation will be to zero the instrument. Whenever we zero, we're using the ambient atmosphere as the instrument's zero reference point. 2 processes are going to take place when the instrument zeroes. The first process will be that the toxics in your combustible sensors will be set to 0 to eliminate any type of negative or positive drift. The second process that the instrument will do during zeroing is it'll calibrate the oxygen sensor to the room air at 20.9%. We always want to ensure that whenever we zero the instrument, that we zero only in clean air. If there's any contaminants in the air, that'll become part of the instrument's zero reference point. For example, let's say we zeroed the instrument, but in the environment was 5 ppm of carbon dioxide. When I go outside to a true clean air environment, my CO sensor will now read a -5 because the 5 ppm I told it was 0 will have disappeared and the instrument will have no choice but to then go negative. So we always zero in clean air. The third thing we're going to do with the instrument before we use it is we're going to take it through a functional test, otherwise known as a bump test. What a bump test is designed to do is to verify sensor and alarm operation. By applying calibration gas or bump gas to the instrument's going to then be challenged by the gas to ensure functionality, ensuring that the sensors do see gas, and when they see the gas, that they go into alarm. This should be done before each day's use. The last step before we use the instrument is to clear our peak readings. What peak readings are is the instrument will store the highest toxic and combustible reading along with the lowest oxygen reading since last time the peaks were cleared. Now peak readings are used that if I'm in a confined space and the instrument starts going to alarm, the user's not going to want to sit there and start looking at the readings. Rather, they're going to want to exit. Now upon exiting, they can then check the peak readings to see what that concentration was that they were exposed to. Since the instrument will record only the highest toxic and combustible and the lowest oxygen reading since the last time the peaks were cleared, the user would have no idea if they're their peaks or somebody else's peak from another time. Turning off the instrument does not clear the peaks. In fact, removing a battery pack will not clear the peaks. Peaks are stored in something called non-volatile memory, written in the code on the EEPROM. And the only way to clear these peaks is to take it through the peak clear mode. Now, the reason why we write them in the code, and the reason why they do not clear if you turn off the instrument, is for accident investigation purposes. God forbid somebody goes down on a job site with one of our instruments on their side. It may be a couple days before they find the body. The battery pack will long since be dead, but the peak readings will still be there, acting kind of like a black box showing the highest concentration that person was exposed to. By clearing the peaks as our last step, we're ensuring that any peak we see is our peak and not somebody else's peak from another time. So let's look at step number 1 of turning on the instrument. To turn on the instrument, we're going to press and hold the on-off enter button until the instrument actually turns on. The screens we'll see appear on the instrument during startup. This first screen will be the MX6 hybrid, showing us also the version software that is currently installed in that instrument. The second screen the user may see will be a contact screen. The contact screen gives us the web address and also the phone number of Industrial Scientific. The third screen that will come up will show us the sensors installed. With that, it may also show us user name and company name if so programmed into the instrument. And then that'll take us then to our real-time operation screen. Our real-time operation screen shows us the sensors installed along with the actual gas readings, but there are optional screens that may appear. These optional screens will appear if the instrument has been configured to show such screens. The first screens that may appear might show you either days until or the days since last calibration. Another screen that may appear if programmed is it may ask the user to zero the instrument during startup. The next screen up may ask us to bump test the instrument prior to use. Or it may actually come up and let us know that a new sensor has been installed. That way, if someone has reconfigured this instrument since last time it's been used, the user will get notification that this instrument is not the same configuration that they may be used to. What you're looking at now is the real-time operation screen. This is our regular gas reading mode. This is where we're actually detecting the gas in the environment. What you'll see is on the real-time operating mode, it'll show you the sensors installed along with its gas readings. Lower left-hand corner is your battery runtime indicator. There's little segments inside the battery runtime indicator to give you an indication of battery runtime. If the battery runtime indicator is completely filled with its indicators, then you have the full complement of runtime, but those segments will disappear, showing battery runtime loss. You also have a data log configuration that also may appear on a display letting you know how your data logger is currently configured. A PID response factor may also appear on your display as well. This is showing you how your PID is correlating its reading, and as we see in this example, the PID reading is going to correlate its reading in accordance with isobutylene. A time indication may also appear on the instrument to let you know the current time. Any gas reading that appears on the instrument's display in red is going to be an indication that that particular sensor is in alarm. Not only will the gas reading be red, but it's also going to increase in font to give us a visual indication that that particular sensor is in alarm. Our second step of operation is going to be to zero the instrument. To zero the instrument, we're going to press the on-off enter button 2 times, bringing up 3 different drop-down options: View, Sensor, and Data. By pressing a right arrow, we'll be able to highlight Sensor. Pressing the on-off button, and that will then bring up Zero All. At this point, it's going to ask me if I truly want to zero all of my sensors. Clicking OK will start the zeroing process automatically. The first thing the instrument will do is take my toxics and combustibles and set them to 0, eliminating any type of negative drift. The next thing the instrument will do is calibrate the oxygen sensor to the room air. We want to ensure that whenever the instrument is zeroing, that we zero only in fresh air, because the O2 calibration is going to be based on purely the ambient atmospheric conditions. So if your oxygen concentration is anything other than 20.9, it may skew your oxygen calibration. Upon completing the zeroing, the instrument will show you the condition of your zeroing. The little green passes indicate that those particular sensors have passed their 0, where a failed indication would be my indication that particular sensor has failed its 0. So once again, to see the zeroing of the instrument, we're going to press the center button 2 times, brings up a drop down, right arrow once to bring up 0, on off again, and if we press it a 3rd time, it's then going to ask us if we want a 0. Press OK, and the zeroing of the instrument will start. It's going to take your toxics and your combustibles and set them to 0 automatically. Upon completing this, it'll then automatically start the calibration of the oxygen sensor. So at this point, the oxygen sensor is calibrating itself to the room air. As we said previously, we always want to ensure we do this only in fresh air, because the O2 full span and that O2 calibration is based on the oxygen concentration in the ambient atmosphere. Once again, if this oxygen concentration is any other number other than 20.9, it's then going to show a skewed calibration. But upon completing this, it'll show you that the zeroings have passed. Pressing on off again acknowledges. On off again takes you back to real time.